Okay, so hopefully this is easy for you at this point. At least that's what I'm hoping. But let's go through it anyway. So our objective today really is we're going to be solving systems of linear equations. And I'm going to give you what that means, okay? Systems in math means two or more, okay? Systems means two or more. We'll just say two equations because we won't do more than that until we get to algebra 2, and then we'll do three-dimensional graphing. And linear means just straight lines, right? So in a nutshell, what we're looking at is how two lines intersect, right? So if I had a line and I got another line, what we're trying to do is really find out how they intersect. But we're not always going to do it by graphing, because graphing seems to be the most tedious way to do it. But when we get an answer, our answer is some point. It really is. That's our answer. Even though we won't graph it, we'll get an answer, because it's easier to do it without graphing. So when I take a look at number 1, hold on, it's November, no, that's a bad looking, November 8th. Look at number 1. There's a couple ways to do it. Grace, you could bring over the 2i, right? I'm speaking to Grace because you like it that way. And it says by any method, okay? I'm going to do it by substitution, but your way is fine too, okay? I'm going to do it by substitution only because I see that I have x already solved by itself, okay? So when I do substitution, I like to write them side by side. 2x minus y equals 3, and x equals negative 2y minus 1. Okay, I like to do that because then I have room to work. I'm going to take my negative 2y minus 1, and I'm going to replace x with that. So instead of writing x, I'll write what x equals, which is my negative 2y minus 1. Okay, so, excuse me, I'll go 2, and I'll put my negative 2y minus 1 minus y equals 3. Okay? So instead of writing x, I just replaced x with what x equals. Now, let's distribute. This times this, right? We're going to simplify it. Negative 4y minus 2 minus a 1y equals 3. I got a negative 4y and a negative 1y. That makes a minus 5y minus 2 equals 3. I'll go plus 2, negative 5y equals 5. Divide by negative 5 on both sides. And I get y equals negative 1. Okay, I've got one answer. Now, to get the x value, let's take this negative 1. I'm going to put negative 1 in for y. Instead of writing y, let's replace y. Let's replace y with negative 1. Okay, so I'll go, okay, x is equal to negative 2. I'm going to replace y with what y is equal to, negative 1 minus 1. And I'll simplify. Negative 2 times negative 1 is a positive 2. 2 minus 1 is 1. So my answer is a point. So my point is going to be the point x, y, 1, negative 1. Okay? Thumbs up? Good. There's one thumb up. 1, 2, 3. There we go. There's my thumbs up. Okay? And you can do this tomorrow. Okay? Number 2. Well, they're lined up. X's, y's, equal signs, numbers. So I'm probably going to tackle this one with the addition method, but I need to make something opposite. I can make this a negative 2. I can make that a negative 4x, or that a negative 3y. It does not matter. It does not matter. I think what I'll do is I will make that a negative 3y. It doesn't matter. So I'm going to multiply by negative 3. I'm going to cancel the y's. Somebody else might argue and say, Mr. Davies, let's cancel the x's. Both answers are correct. I'm going to cancel the y's. If you want to cancel the x's, that's okay too. So I'm going to rewrite these two equations. Okay? So I'm going to keep my first equation the same. 4x plus 3y equals 14. But I'll rewrite my second equation as a negative 6x minus 3y equals negative 9. Because I multiplied everything through. Okay? So if I were to add them, my y's will cancel. I'll have a negative 2x. Y's are gone. Equals, what's that, 425, what's that, a 5? No, come on, I can do this. Is that 5? Huh? That's 5. Divide by negative 2, divide by negative 2, x is equal to negative 2.5. That's a decimal. That's okay. I can deal with that. So the easier one to do it is probably put this negative 2.5 probably right there. That's the easier one to put it into. Smaller numbers. So I'll take this second equation. I like this one because it's smaller numbers. And instead of writing my x, I'll replace x with what x is equal to, which is negative 2.5. Right there. 2, and I'll replace x with a negative 2.5 plus y equals 3. That's a negative 5. 2 times negative 2.5 is a negative 5. I will plus 5, y is 8. Okay, so my answer, right, is a point x, y, and so I get negative 2.5, 8. All right, let me see. You guys got it? Thumbs up? Okay. If it's sideways, thumbs okay too. Okay, good. Okay, number 3. Okay, number 3. What I'm going to do is, I got to multiply, gosh, to make this one easy, I'm probably going to multiply this one by 2. Who said that? Who said 2? Totally agree. Totally agree. Because that makes a negative 4x and a 4. So you guys see that? So let me rewrite equation 1, negative 4x plus 10y equals negative 42, and 4x minus 10y equals 42. Oh, something weird's going to happen. Everything's going to disappear. Everything. That's gone. That's gone. That's gone. So we really get this thing like 0 equals 0. So no x's, no y's. So it's either going to be no solution or all solutions, right? So let me ask you the question. Does 0 equal 0?
Yes.
All the time? Right?
Yes.
So let's go with all real numbers, because it turns out to be the same line, just disguised, graphed on top of each other, so it's all real numbers. Okay? Or the cursive R, which I like, because I'm always afraid I'm going to misspell something. It's cursive R is a symbol for all real numbers, okay? I know, you guys never learned cursive, did you?
Oh, no, we did it. She just did like a print R.
Yeah, that's all right. I know. You poor kids, you never learned cursive.
We did, but we don't use it.
Yeah. Yeah, that's great. Okay, number 4. I know the answer.
Get the lesson that I was.
Right, I'm looking at number 4. I know the answer. I don't even need to do any work. I already know the answer. Anybody know the answer to this one? Why do I know they're parallel? Why do I know they're parallel? Say that. I heard the S word. Because of what?
Slow.
Same slope. So we're smart, right? This one starts at 7, and this one starts at negative 5. Watch my hands, right? And they're going to go up 2 over 3. Up 2 over 3. Are they ever going to intersect?
No.
So what's my solution?
Parallel.
No solution. No solution. Okay. All right, number 5. I'm going to need a piece of graph paper, but that's easy. I'll just find my graph paper around here somewhere. All right. Give me a second while I get a piece of graph paper out. So, slide this up. Put my x-axis and my y-axis. And I'm going to start at 5, right? Oh, you can't see that. I'm going to start at 5 on the y-intercept. That's a y-intercept. 1, 2, 3, 4, 5. Then my slope is down 3 over 4, 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 forever and ever. Is this going to be a solid or dashed line? Let's go solid. So go solid. Because of the equal sign, right? So solid line. I'm going to do this one. I like colors. Colors are cool. I'm going to do this one in green. So if I read this, y is, what's this say? Y is what? Greater than or equal to. So everything above. My second line, I'm going to start at -4 on the y-axis. And then up 2 over 3. Up 2 over 3. That's my slope. Up 2 over 3. Up 2 over 3. Up 2 over 3. Solid or dashed line? Dashed, because there's no equal sign, right? That one's dashed. Dashed. All right, good. So just going to make it look like this, because it doesn't equal the line. Everything, it's going to be everything below the line, but nothing, but not the line. So everything below. I'm sorry, everything below the line. I'll do that one in orange. So here's my line, everything below. So then all I want you to do is just to make this look a little darker than the rest, just shade and make it look darker than the rest of the region that works for all of these points is right in here. Just make that darker, okay? How's that? Thumbs up, can you do that tomorrow? Good, good. All right, turn the page. Okay, now, is the point -2, -3 a solution? There's two ways. You could graph this and see where the point is. In fact, I'll do that. I wouldn't expect you to do this. There's an easier way to do it, right? I mean, you could say, well, gosh, I'm just going to graph it. All right, I know that. I wouldn't expect you to do this, okay? If I do my cover-up method, I've got a -2.5. I've got a -5. Okay, and I'm going to have greater, actually it's going to be less than. See, it's kind of confusing. -2, -3, it looks like it is, yes. Now, I would not do this way. Isn't that a pain? Well, what I would do is just plug in these points. X, Y. So instead of writing X, I'm going to write -2. Instead of writing Y, I'm going to write -3. And let's see if that answer is greater than or equal to 5. Well, it's a +2. That's a +6. Is 8 greater than 5?
Yes.
So this point must be in this region. In fact, it is, isn't it? So we say yes. Okay, you ready? Write a system of linear inequalities to represent this. So I've got two lines, and all I need is the equations. Okay, so I know I'm going to be annoying. Y equals what? Y equals? Y equals what? Okay, equation 1. Y equals, let's see, it goes up 1 over 2, up 1 over 2, x plus 2. I'll show it. Okay, here it is. Right? I'll show it, right? So we start at 2, right? Up 1 over 2. That makes sense? Except we shade it, and it's dashed, right? So we're going to change this to less than. Not less than or equal to, but just less than, okay? So let's go, y is less than 1/2 x plus 2, okay? Now the second equation, equation 2 is right here. y equals, let's see, I'm going to go, looks like it's down 2 over 3, down 2 over 3, plus, whoops, minus 2. Almost made a mistake. Let's see, here we go. Starts at -2, right? And then I'm going to go down 2 or 3, right? But it's shaded, right? And it's below it, so it's less than. Now I got a solid line, right? So I'm going to go less than or equal to, okay? So y is less than or equal to -2/3 x minus 2. So I just like to write them together. You wouldn't have to do that, but I would put these two together as a system because this together, these two together make that system. Okay, can you do that tomorrow? Okay, and then I think I have the easiest question tomorrow also is testing points, asking points, is this point in this region, yes or no, okay? Now, if it's on a dashed line, it's going to be no. Number 8, last one. You and a friend are selling sweatshirts. The cost of a sweatshirt is X dollars, and the cost of letters on each sweatshirt is Y dollars, okay? All right, that makes sense. So how many sweatshirts do you think you're going to buy? Probably one, but let's see if we can set up an equation, okay? So I've got sweatshirts, and I've got letters. Okay, I've got your costs, and you got your friends. So we've got, here's your sweatshirt, and here's your friends. So the cost of a sweatshirt is X dollars, and the cost of the letters is Y dollars. Your name has 12 letters, so you're going to buy a sweatshirt plus 12 letters, and it costs you $58. Okay, I'm assuming only one sweatshirt, right? So your friend's going to buy a sweatshirt. A fiend, huh? Look at that. I can sure spell, can't I? And your friend's going to buy a sweatshirt and has 9 letters for $49, okay? We could find the cost. So let's get rid of the X. Okay, with elimination to get rid of the X, right? Make it easy. I'll multiply this by -1, and I'll rewrite this as a negative X minus Y equals -49. And then when I add them, I'll get 0 X's. 3Y equals, let's see, what's 58 minus 49? I get 9. Divide by 3, Y is 3. Okay, so this tells me the cost. I know the cost of letters. So our letters are $3 per letter, okay? Now let's figure out what the cost of sweatshirt is. All right, well, cost of sweatshirt is, I'm just going to plug my 3. How about into this one? That looks easier, doesn't it? So I'm going to run out of room, but I'd go X plus 9 times 3 equals 49. I'm just going to put my 3 in for Y to get the value of X. 9 times 3 is 27. Okay. Minus 27 minus 27. X equals, what's 49 minus 27 is 22, right? Okay, so sweatshirts are going to cost $22 a piece. Okay, so the problem you see tomorrow is just like this. I tried to make it easy. I didn't give you a big hard story problem. I gave you a story problem that you should be able to do. All right? Okay, so let me go ahead and stop my video, and then let's go take a math break, okay? Let's go outside.